so let's go through some examples using these motion formulas, constant acceleration formulas. And before we do that though, let's understand that these formulas are very sensitive to the use of positive and negative values for both displacement values and for velocity values. Remember, these formulas, they're all built off of the definition of the constant acceleration formula and the constant velocity formula. Both cases, direction, plus and minus, is extremely important. Keep that in mind. So in this particular example, I have a person walking, going 2 meters a second, maybe a brisk walk, and then suddenly they, at position 0, start increasing their motion, start accelerating, start getting faster. And by final position, after 2 seconds, so I have my little clock and I say that 2 seconds has passed, they're now at 6 meters a second. And they're moving in the positive direction in both cases. If that's happening, one of the things you might want to know is, well, how far did they go? What was their displacement during that time? All right. Well, in the beginning, if you want, you can make a little table and label your variables. Now, in some books and some examples, they will have x2 or x2 and x1. I don't do that. I generally just label it delta x, how much displacement happened, because typically we always say that, we don't always say, but typically, or in many examples, the first position is always your 0 position, where you're starting, just like your first time, your initial time is usually 0 on the stopwatch. So you'll see even on the AP formula sheet, they'll break this down into x2 minus x1. Regardless, in this particular question, that's what we're looking for. How far did this person go? Now, I like to, in the beginning, tell students they can make a little tally of all their given information, because every one of these formulas contains some of these variables. So these variables are all contained here in some way, shape, or form. Not every formula has every one of those variables, but if we list those variables, we can pick the right formula that's going to match what we're trying to do. So we want to know the displacement. The initial speed is positive 2.0 meters per second. Now I'm going to be obnoxious in these examples with the signs, plus and minus, to make you very aware how important they are. The second speed, 6 meters a second, positive. The time is 2.0 seconds. I do not need to put a plus and minus on that. We can only move forward in time. And acceleration, I don't know, nor in some problems would you be asked for it. So I can leave it blank. Could I solve for it? Absolutely. Absolutely. So let's find what we're asking for. So I'm going to look and match this up with the best formula so that I can do this in one step. There are going to be situations later where you're going to get a bunch of variables and you're like, oh, I can get what they're asking for, but I have to use, multiple steps. I have to maybe use this formula to get a variable, then use it in that formula. But a lot of the times, if you read it correctly with enough information, you can do this in one formula. You've got to pick the right one, though, that matches your information. Does it have what you're looking for, or does it have all the other pieces? So in this particular case, I want displacement, I have velocities, and I have time. So if I look here, I have velocities, I have time, but they're not looking for displacement. I could find acceleration though, but that's not what I'm looking for. This formula I'm looking for displacement. I have velocities. I have time. Perfect. That's the one. And so you just go and plug in what you need. And if you solve it, there you go. And actually, what I should do, the reason I wrote the formula without substitution up top is important because typically you'll be asked a question, and for my class and the AP people, they love to know your thinking. And so if you're asked a question and you show the formula that you're going to start with without substitution in it, it will very clearly indicate to the reader, myself or some other AP grader or another physics teacher, what your mind's thinking. Oh, I'm here in constant motion. Constant in the motion formulas with constant acceleration. So you're gonna, in my class, going to be required. It's not an option. You're required to show at least 3 minimal steps for solving problems. 1, show me which formula you're starting off with without any substitution. Because sometimes when you throw in the substitution, it doesn't clearly show where your head is, and you might mix up formulas and you might mix up numbers. And so no, I want to know what formula you're using. Then the next step, you have to show me the substitution. And the last step can just be the answer. I don't need to see the algebra getting from the substitution to the last number. If you want to write it out, that's fine. And that last answer, please have nice and indicated as a box, circle, or something. Don't let me guess where your final answer is. I could or should also indicate that this is a positive displacement. Again, being obnoxious with the signs. Okay? All right, I'm going to clean this up and get to another example.